contractor likely installed Class 1 Division 2 wiring to adhere to the National Electrical Code, or NEC, standards for hazardous locations. Although diesel fuel is classified as a Class Roman III flammable liquid, the NEC mandates that electrical wiring and equipment areas where Class Roman III flammable liquids are stored or handled must comply with Class 1 Division 2 requirements. This is due to the potential for Class Roman III flammable liquids to create an explosive atmosphere under certain conditions, such as spills or leaks. Class 1 Division 2 is an area where flammable gases, vapors, or liquids are present but are normally confined within closed containers or closed systems from which they can escape only through accidental rupture or breakdown of containers or systems, or in the event of abnormal operation of equipment, or in which flammable gases, vapors, or liquids are normally prevented by positive mechanical ventilation, and which might become hazardous through failure or abnormal operation of the ventilating equipment, or that is adjacent to a Class 1 Division 1 location, and to which flammable gases, vapors, or liquids might occasionally be communicated unless such communication is prevented by adequate positive pressure ventilation from a source of clean air, and effective safeguards against ventilation failure are provided. Class 1 locations are those where flammable gases or vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. The NEC defines three classes based on the type of hazardous material present. Firstly, Class 1 covers flammable gases, vapors, and liquids. Secondly, Class 2 deals with combustible dusts. Thirdly, Class 3 addresses ignitable fibers and flames. Each class is further divided into divisions based on the likelihood of the hazardous material being present in an ignitable concentration. Division 1 indicates that the hazardous material is normally present or may be frequently present. Division 2 signifies that the hazardous material is not normally present but may accidentally exist. To determine the appropriateness of Class 1 Division 2 wiring, a more in-depth look at the specific requirements is helpful. Article 500 of the NEC covers hazardous locations in detail. Specifically, Article 514 addresses motor fuel dispensing facilities, which, while primarily focused on gasoline, can provide useful guidance when dealing with diesel fuel. Although diesel is less volatile than gasoline, potential hazards still exist. The NEC doesn't specifically outline wiring requirements around diesel fuel tanks in a straightforward manner. The general guidelines for flammable liquids and hazardous locations are applied. The classification of Class Roman III flammable liquids is determined by their flash point, which is the lowest temperature at which a liquid produces sufficient vapor to form an ignitable mixture in air near the surface of the liquid. Diesel fuel typically has a flash point above 100 degrees Fahrenheit, classifying it as a Class Roman III flammable liquid. The NEC guidelines aim to minimize the risk of ignition in areas where flammable materials are present. Therefore, even if the risk appears minimal, adhering to the strictest safety standards is crucial. The specific requirements for Class 1 Division 2 wiring include using explosion-proof enclosures for electrical equipment, sealing conduit to prevent the propagation of explosions, and employing intrinsically safe circuits. Explosion-proof enclosures are designed to contain any explosion that may occur within the enclosure, preventing it from propagating to the surrounding atmosphere. Sealing conduit involves using special fittings and sealing compounds to block the passage of gases, vapors, or flames through the conduit system. Intrinsically safe circuits limit the amount of energy available in the circuit to a level that is too low to ignite a flammable atmosphere. While it may seem like Class 1 Division 2 wiring is an overcautious approach for diesel fuel tanks, it represents the most secure and code-compliant method. By complying with NEC requirements, the contractor minimizes the potential for fires and explosions, safeguarding people and property. Therefore, understanding the reasoning behind the contractor's choice clarifies why such stringent measures were implemented. Furthermore, consider that local jurisdictions may have additional requirements beyond the NEC. Always consult with local authorities and regulations to ensure full compliance. The NEC serves as a minimum standard, and local codes can be more stringent depending on the specific circumstances and risk assessment of the area. To further evaluate the installation, it is useful to review some specific NEC sections. Firstly, NEC Section 500.5 details the general requirements for area classification. Secondly, NEC Section 501.10 outlines the wiring methods permitted in Class 1 Division 2 locations, including the use of rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and cable types specifically approved for hazardous locations. Thirdly, NEC Section 501.15 covers sealing requirements to prevent the passage of gases, vapors, or flames. Proper sealing is crucial to maintain the integrity of the explosion protection. Fourthly, NEC Section 501.125 specifies the requirements for intrinsically safe systems, if applicable. Intrinsically safe systems are designed to limit the energy in electrical circuits to a level below what is required to ignite a hazardous atmosphere. Fifthly, NEC Section 514.3 provides additional requirements for motor fuel dispensing facilities, which can offer guidance on wiring and equipment in similar applications involving flammable liquids. Moreover, it's essential to understand the purpose of each component used in Class 1 Division 2 wiring. Firstly, explosion-proof enclosures are robust housings designed to contain an internal explosion without causing external hazards. These enclosures are tested and certified to withstand specific pressure levels. Secondly, sealing fittings are installed in conduit runs to prevent the propagation of flames or vapors. These fittings must be filled with a suitable sealing compound that effectively blocks the passage of hazardous substances. Thirdly, intrinsically safe barriers are used to limit the energy in electrical circuits. These barriers are designed to prevent excessive voltage or current from entering a hazardous area. Fourthly, specially approved cables, such as those with a Type TCER or MCHL rating, are designed to withstand the harsh conditions often found in industrial environments. These cables are resistant to chemicals, abrasion, and moisture. Additionally, proper grounding and bonding are essential to minimize the risk of static electricity buildup, which could potentially ignite a flammable atmosphere. The NEC provides detailed requirements for grounding and bonding in hazardous locations to ensure electrical safety. The use of Class 1 Division 2 wiring in the vicinity of diesel fuel tanks, while seemingly stringent, demonstrates a commitment to safety and compliance with industry standards. By adhering to the NEC and implementing appropriate safety measures, the risk of fire or explosion is significantly reduced, protecting both personnel and property. Furthermore, it's important to document all aspects of the installation, including the area classification, wiring methods, equipment specifications, and inspection records. This documentation can be valuable for future reference and for demonstrating compliance to regulatory authorities. Regular inspections and maintenance are also crucial to ensure that the electrical system continues to operate safely and effectively. These inspections should include checking for any signs of damage, corrosion, or deterioration, as well as verifying the integrity of explosion-proof enclosures, sealing fittings, and grounding connections. Understanding the potential hazards associated with flammable liquids and the requirements for hazardous locations is essential for anyone involved in the design, installation, or maintenance of electrical systems in these areas. By following the guidelines outlined in the NEC and implementing appropriate safety measures, electrical professionals can help to prevent accidents and ensure a safe working environment. Furthermore, consider the role of training and education in promoting electrical safety. Providing employees with the knowledge and skills they need to work safely around flammable liquids and electrical equipment is essential for preventing accidents. This training should include instruction on the proper use of personal protective equipment, the identification of potential hazards, and the procedures for responding to emergencies. The decision to use Class 1 Division 2 wiring for diesel fuel tanks reflects a proactive approach to safety and compliance. Although diesel fuel may not present the same level of risk as more volatile substances such as gasoline, the potential for fire or explosion should never be underestimated. By implementing stringent safety measures, such as Class 1 Division 2 wiring, the risk of accidents is minimized and a safer working environment is created. In addition to the technical aspects of Class 1 Division 2 wiring, it's also important to consider the human factors that can contribute to electrical accidents. Human error, complacency, and lack of awareness can all increase the risk of incidents. Therefore, it's essential to foster a culture of safety in the workplace, where employees are encouraged to report potential hazards and to follow safe work practices at all times. Regular safety meetings, toolbox talks, and safety audits can help to reinforce safety awareness and to identify areas where improvements can be made. It's also important to ensure that employees have access to the necessary resources and support to perform their jobs safely. This includes providing them with the appropriate tools, equipment, and personal protective equipment, as well as access to relevant safety information and training materials. By addressing both the technical and human factors that contribute to electrical accidents, organizations can create a safer and more productive work environment. In conclusion, the contractor's decision to use Class 1 Division 2 wiring for the diesel fuel tanks reflects a commitment to safety, compliance, and best practices. While it may seem like an overcautious approach, it is consistent with the requirements of the NEC and helps to minimize the risk of fire or explosion. By understanding the reasoning behind this decision and by implementing appropriate safety measures, electrical professionals can help to create a safer working environment for everyone. Remember that local codes can be more stringent depending on the circumstances. Another important aspect to consider is the regular inspection and maintenance of the electrical system. This includes checking for any signs of damage, corrosion, or deterioration, as well as verifying the integrity of explosion-proof enclosures, sealing fittings, and grounding connections. Any issues identified during these inspections should be addressed promptly to prevent potential hazards from developing. Furthermore, it's important to keep accurate records of all inspections, maintenance, and repairs performed in the electrical system. These records can be valuable for future reference and for demonstrating compliance to regulatory authorities. In addition to the technical aspects of the electrical system, it's also important to consider the administrative controls that can be implemented to enhance safety. These controls include developing and implementing safe work procedures, providing regular training to employees, and conducting periodic safety audits. By implementing a comprehensive safety management system, organizations can create a culture of safety and minimize the risk of accidents. Consider also the evolving nature of technology and regulations. Staying informed about the latest advancements in electrical safety and the changes to the NEC and other relevant standards is essential for ensuring compliance and maintaining a safe working environment. Subscribing to industry publications, attending conferences and workshops, and participating in professional organizations can help to keep electrical professionals up to date on the latest developments. It is also important to know that the specific requirements for Class 1 Division 2 wiring can vary depending on the specific application and the type of equipment being used. Therefore, it's essential to consult with qualified electrical engineers and other experts to ensure that the electrical system is designed and installed in accordance with all applicable codes and standards.